So here we're going to have a look at how to set the handrail and how to get the space between the centre line coming up through this flight, round the corner and back up through the next flight. What we're going to use for this one, very simply, is a full going. So we're going to work using from riser line to riser line as our distance between handrail centre line to handrail centre line. Here you can see a flight coming up through, turning through 180 degrees and going back up again. And when we use a full going, this will come to level halfway through the turn. The same spacing will work if we have a landing between the two flights. So if we imagine taking this flight out that was coming back up here, moving it back over so it's sitting over top of the flight beneath, and adding the landing in between. By using one going, again our handrail will come to level at 90 degrees through the turn, which maintains the landing height and keeps the curves flowing nicely. So let's go ahead and have a look. In fact, before we do that, if we actually hide the handrail away here, you can see the centre line coming down through the radius of diameter at the end, all the way back round into the next flight, and from that we can come down through the spindles to work out where our stringer face is, or our landing fascia. And whether this be a landing here or a stringer fascia, that the fascias and the stringers will both be in the same position. So let's go ahead and see how we draw this out. So here we have a representation of a plan view. We have a flight drawn in here with our riser lines. We have a representation of the nosings put in. Here we can see the handrail centre line. Offset by half a spindle's width, we have the stringer face and then the nosing outside of the stringer face. What we want to do is find out where all this lot sits. There's only two real positions that can be used or that work out. One is where we have half a going, space between the two handrail centre lines. When we use this, where the turn is in the handrail, the pitch will carry on as if we're coming down through the flight. So that turn will carry on pitching all the way round and straight back into the next flight. The other option is where we use a complete going between the handrail centre lines. So here we have a complete going, and that's the same distance as here to here. Then when we do this, the handrail will come round and turn, but it will come to level centrally in the turn and then back round into the pitch of the wreathing one. So let's have a quick look at this on here, and here you can see it all drawn in. So here you can see A is 308 millimeters for those working in metric, and in fact it's still the same for those working in imperial, still 308 millimeters, but A is equal to A here. So our handrail centre lines are that distance apart. Here you can see the handrail turn put in, and that still keeps all our centres for our spindles, and from that we can work off to get our stringer face coming down through each turn. Obviously if we use half a going, then that all comes in a lot closer. If you go any smaller than half a going, you'll probably find that the handrail will not turn and you can't get the moulding around. If you're coming out onto the landing, here we've drawn it in with a tread here and the treads here, and you can see that those two risers both sit in line with each other, and that's really the basic principle. If you're going out onto a landing here, whether it's a landing coming back round or a landing going off to the side and having a big atrium, by using the full going as our radius as well as our diameter, then that radius will come round and that will come to level before we head off into our landing. And that's really all there is to it.